Deep within warm soil, millions of fire ants dwell in unyielding harmony. Their reddish bodies pulse with relentless energy, moving purposefully through tunnels in the earth. This colony is a complex network, a silent army orchestrated by unseen signals and an unbreakable social code. Among these tiny warriors, survival depends on cohesion, and their presence hints at a world governed by. This story reveals the secret lives of fire ants, Solenopsis, across varied warm regions. It focuses on their fierce defense strategies and mysterious chemical language that binds the colony. These ants thrive through coordinated swarms and painful stings designed to protect their community. Yet their invasive spread casts pressure on local ecosystems, prompting careful management efforts to understand and control their impact. At the heart of their underground fortress, workers patrol tirelessly. Their bodies coated with glands producing distinctive chemicals, these ants communicate alarm and rally forces instantly. Each signal triggers a complex cascade of reactions, transforming individual ants into a coordinated defensive unit. When danger approaches, their response is swift and merciless. A unified wall of fire ants rely heavily on their stings as a deterrent and weapon. Injecting venom that induces sharp pain, they can overwhelm threats through sheer numbers. This defense is not random, but strategically organized, as chemical cues guide swarms to vulnerable targets. The collective instinct to guard brood and queen compels even the smallest worker to engage fiercely, revealing the evolutionary pressures that shaped such These insects extend their dominance by expanding nests and establishing satellite colonies in new territories. As invaders, they challenge native species, altering the balance of life within their ecosystems. Their success in colonization ties closely to their aggressive defense and communication systems, survival mechanisms that ensure the colony's persistence despite environmental resistance. Attempts to curb their near the entrance of a fire ant colony, subtle vibrations ripple through the soil. Workers patrol the perimeter vigilantly, ready to respond to any sign of intrusion. Their antennae detect minute disturbances, triggering a swift mobilization. Chemical signals spread rapidly, summoning defenders in a coordinated wave that combines precision and collective vigilance. When a potential threat approaches, fire ants increase their activity with a tense urgency. Mandibles open as they converge on the source, releasing alarm pheromones into the air. This chemical communication acts as an invisible rallying cry, sharpening alertness across the colony. The swarming defenders reveal a sophisticated system balancing aggression with strict organization. Each worker contributes to the colony's defense by performing specialized roles dictated by their physical form and sensory perception. Scouts first identify intrusions, quickly relaying location through subtle touch. Meanwhile, soldiers with robust mandibles stand ready to engage intruders directly. Their painful sting a deterrent against unwelcome visitors, safeguarding the colony's vital nest chambers. The defensive response unfolds with relentless precision. As more ants arrive, their coordinated movement creates an imposing swarm around the disturbance. Moving almost as one, their collective behavior maximizes the colony's defensive reach. This strategic deployment ensures the nest remains secure, even under persistent pressure from larger predators or competing insect species. Despite their aggressive tactics, fire ant defense is also shaped by environmental pressures. Populations manage resources carefully, responding to threats without needless expenditure of energy. In navigating the balance between vigilance and survival, these insects reveal complex ecological strategies essential to their persistence across diverse warm habitats. Under threat, fire ants unleash a hidden chemical language, invisible signals that ripple through the colony. These alarm pheromones, secreted from specialized glands, swiftly alert workers to danger. Through scent alone, an intricate network stirs to life, setting off a cascade of movement and readiness among the thousands of tiny defenders. Moments after detecting a threat, these chemical messages encode urgency, directing ants with remarkable precision. The colony's response is rapid and synchronized, with the scent trail guiding each ant to converge on the source, their coordination driven not by sight or sound, but by these subtle molecular cues. The power of alarm pheromones lies in their immediacy and reach. Even ants far from the disturbance can detect the signal's decay in the air, triggering defensive postures. This swift transmission transforms the colony into a unified force, prepared to defend its home through overwhelming numbers and a fierce, coordinated attack. Within this chemical communication lies the colony's adaptability. Different pheromone blends can adjust the intensity of the response, mobilizing only the necessary number of workers. This economical use of resources protects the colony's stability while maintaining readiness against repeated or escalating threats. As alarm pheromones permeate the air, the collective energy mounts, revealing a complex social mechanism. It is a potent defense system, where pain-inflicting swarms are summoned not randomly, but by these carefully released scents, a biological alarm that resonates across the colony's nerve center, shaping survival strategies in an increasingly hostile environment. Beneath the surface, fire ants navigate a complex world of scent. Their bodies are coated with chemical signatures, unique blends that serve as identity cards within the colony. These subtle cues allow them to recognize each other, distinguishing friend from foe without sight or sound. This olfactory language is essential for maintaining the colony's boundaries amid the dense and chaotic environment they inhabit. When invaders approach, fire ants rely on these chemical profiles to detect intruders. Foreign scents trigger a rapid response, mobilizing defenders to swarm and protect their nest. This chemical recognition system underpins their coordinated defense strategies, allowing them to maintain order and repel threats effectively. It is a silent but aggressive communication method that shields the colony from disruption and ensures its survival. Each ant continuously exchanges chemical signals by touching antennae and passing across colony members. This ritual refreshes the collective scent, reinforcing group unity and facilitating acceptance. Variations in these chemical markers can reveal shifts in colony dynamics or the presence of foreign ants attempting infiltration. Through this nuanced chemical dialogue, fire ants preserve the integrity of their The chemical identity cards are deeply tied to the ant's habitat, reflecting adaptations to warm climates across continents. Their ability to maintain distinct scent profiles enables them to spread invasively, often outcompeting native species. This mechanism also presents challenges for ecosystem balance, as their relentless defense and expansion disrupt local biodiversity. Understanding these chemical cues in the face of escalating pressures, researchers study these chemical signatures to develop targeted control methods. By manipulating scent cues, it may be possible to confuse or deter fire ant colonies, reducing their aggressive incursions without harmful widespread effects. This intersection of chemical ecology and conservation represents a cutting-edge approach, one that aims to curb the ants' expansion while preserving fragile within the warmth of their environment. Fire ants reveal a remarkably synchronized defense strategy. When a threat nears, thousands respond in unison, their movements guided by chemical trails and tactile signals. Their tiny bodies converge rapidly, forming a moving shield that protects the colony. This collective behavior minimizes individual risk while maximizing defensive strength. The fire ant's famed painful sting is not delivered in isolation. Instead, these insects execute coordinated swarming attacks, each sting reinforcing the chemical alarm. Pheromones released during an attack alert nearby ants to converge swiftly, intensifying the assault. This strategic cooperation deters predators far larger than themselves, illustrating how social insect colonies balance aggression. Chemical communication is central to the ants' remarkable coordination. As the first defenders engage, compounds exuded from their bodies serve as invisible signals, rapidly recruiting more workers. This cascading response transforms scattered stings into a surge of concentrated defense. The environment itself can influence these signals, with temperature and humidity modulating the speed and reach of alarm chemicals. Attacks often follow a precise pattern. Scouts identify intruders, release alarm pheromones, and lead others to the source. The collective storm of ants delivers multiple simultaneous stings, each adding to the overwhelming sensory assault. Their combined efforts create a daunting barrier, discouraging persistence from would-be threats. This strategy reflects both an evolved response to predatory pressure. Such aggressive defense can have broader ecological consequences. Fire ants' invasions threaten native species, reshaping local ecosystems where their swarms dominate. Their coordinated stinging and rapid expansion challenge other insects and small animals alike, introducing tension in new habitats. Understanding these tactics informs targeted management efforts aimed at mitigating their invasive spread. Within the labyrinth of a fire ant colony, constant touch and chemical exchange create an intricate web of communication. Antennae brushing against one another transmit vital signals, ensuring every member knows its role. This silent dialogue weaves together the colony's daily rhythm, from foraging to defense, allowing the colony to respond swiftly to threats and environmental shifts. As danger approaches, fire ants rally with remarkable synchronicity. Pheromones released by scouts spread warnings quickly, triggering coordinated swarms ready to protect their territory. Each ant's movements are precisely timed, a product of chemical cues and tactile feedback, forming a living network that can adapt rapidly to external pressures and maintain the colony's survival. The colony's defense strategy hinges on cooperation rather than sheer numbers alone. Fire ants use their painful sting and aggressive posturing to deter intruders. But it is the collective action, guided by chemical signals, that amplifies their impact. This cooperative defense exemplifies how social insects rely on communication to overcome challenges that a single ant could not manage. Environmental changes continuously test the colony's resilience. When obstacles arise, chemical messaging shifts focus. Scouts lead the way through obstacles, recruiting workers to new paths or resources. These subtle shifts in chemical language enable the colony to adapt dynamically, maintaining cohesion and function even amidst disturbance, ensuring the colony's persistence in unpredictable surroundings. Yet, this sophisticated teamwork contributes to their invasive success across continents. Their ability to defend territory aggressively and coordinate large-scale responses places pressure on native ecosystems. Understanding this intricate social communication is essential for managing their populations and mitigating ecological impacts, revealing the delicate balance between natural behavior and environmental challenges.